In this example, we're going to take a given limit, and given an epsilon, we're going to find a positive delta. So what this says is for the limit is x approaches 5 of the function square root of x minus 1 equals 2. We're going to find delta greater than 0, so that just means a positive delta, such that epsilon is equal to 1. And what this means, if we think about it in layman's terms, this says find delta such that, so we're going to use our definition, and remember the definition says f of x minus the limit has to be less than epsilon. So we have our function x minus 1, take away the limit, which is 2. That needs to be less than my epsilon value, which is 1. And we wish to do this so that 0 less than x minus my c value, and my c value here, the number that we are approaching, is 5, so that that is less than delta. So the first thing I'm going to do is take this right here, my epsilon equation, f of x minus the limit is less than epsilon. I'm going to take that and solve the inequality for my x value. So this is my first step here. I've explained what we're going to do. Now we're going to do it. I've got the square root of x minus 1 minus 2 needs to be less than 1. So we're solving an absolute value inequality, and we wish to determine an interval which contains x equals 5, on which the inequality is true for any other x that's not 5, okay? Because keep in mind, 5, that value we're approaching in our limit, it's possible for it to be not defined or undefined. So solving an absolute value inequality, I'm going to put -1 on the left. That gets rid of my absolute value bars. I can add 2 to each side. That gives me +1 is less than the square root of x minus 1. Adding 2 to 1 gives me 3. Square both sides. 1 squared is less than x minus 1 is less than 3 squared. Or rather, 1 is less than x minus 1 is less than 9. And then add 1. So 2 is less than x is less than 10. So what this represents here, this is my possible horizontal interval. Okay? Now, what number were we approaching? We were looking at approaching, we were saying as x approaches my c value, which is 5. So basically what we're saying here is that the inequality, the epsilon inequality, it holds true for any x that's between 2 and 10. All right? Which means it holds, or it's true, for all x that are not 5 on the interval. So if we were trying to determine how to choose our delta, we'd think about that interval from 2 to 10. And 5 is a little bit closer to 2 than 10. So I've drawn this reasonable here. So in this case, 5 minus 2, or 5 minus that delta, gives us 3. Over here, 10 minus 5 gives us 5. Now remember, we want the smallest horizontal region. So what we would do here is we would choose delta to equal 3. And if I do that, I choose delta to equal 3. Now I have a smaller acceptable region. I've got 3 units to the left and 3 units to the right. So we're always choosing the smallest of those two differences. All right, remember, x equals 5, that was the value we were approaching. So basically, if I choose some number, say x equals 3 or x equals 7, those are on my interval, then I know I will be within epsilon. Remember, epsilon was equal to 1. I know I will be within 1 unit of 2. So I know my output, if I choose any value between 2 and 8 for my x, my output is always going to be within 1 unit of 2. And 1 unit above and below, that would be an interval 1 to 3. So I'm going to rephrase my answer again on the next slide and show you an image. What we're saying here is that if we take delta, if we choose delta to equal 3 or any other smaller positive value, then the inequality 0 less than x minus my c value, which was 5, less than delta, will automatically place x in that interval between 2 and 10. And it implies that the function square root of x minus 1 minus the limit 2 is less than 1. Or rather, this epsilon information, the function minus the limit less than epsilon, which is 1, is true whenever my delta is chosen, as long as this x minus 5 is between 0 and 3. I choose my delta to equal 3. So let's pull in that image. So here I have the graph of my function. My square root shifted right 1 unit. And so I know, in this case, because the function is defined, that at x equals 5, my y value equals 2. So the limit of the function as x approaches 5 from either side is going to equal 2. So we said epsilon had to be within 1 unit of 2. So I've got plus epsilon and minus epsilon, plus 1, minus 1. So as long as my output is between 1 and 3. And if I choose my delta to be 3 units, minus 3, plus 3, as long as I'm within that window, all of my y values will fall between 1, and if I had chosen 8, we would get the square root of 7. And 1 and root 7 are within my epsilon window, so this works. So I hope that helps you kind of understand what we're doing with the precise definition of a limit.